Esta es la sección 5.2, diferentes técnicas de integración. In this section, I'm just going to go over, I would say, a fairly challenging problem. Give you a couple of you-try problems, which we'll work out in class the following day. And I'll talk about what you can do to get yourself maybe unstuck, or how to progress through a problem if you don't really see where it's going and how you can match it up and so on. So, the first thing I notice is that I have multiple terms in the denominator, which I'm going to go ahead and just try a traditional use of. So I'm going to let u equal 1 plus the square root of x. Okay. And keep in mind this is the same thing as 1 plus x to the 1/2 for a traditional u sub, because now if I try to do a u sub and let du equal the derivative, well, the derivative of this is going to be, if I do the power rule on x to the 1/2, it's going to be a 1/2 x to the negative 1/2 dx. And so if I multiply this 1/2 over, it's going to be 2 du equal to, well, x to the negative 1/2 is square root of x dx. And the problem with this is I let u be the denominator part. So if I would try to rewrite my integral, this is the integral, I would let u equal the denominator. But my du has to have a square root of x in the denominator and a dx next to it. But I have the opposite. I have square root of x in the numerator and the dx next to it. But my du says I have to have square root of x in the denominator, and I don't. So this, at this point, is incorrect. Like, I already used up the denominator, the 1 plus square root of x. I don't have the correct du matching up, so this is incorrect. But what I could do is maybe try doing a u manipulation. So over here on this part, I'll try doing a u manipulation. Because I could easily do is solve for the square root of x. So I'll have, if I subtract the 1 over, it's going to be a u minus 1 is equal to the square root of x. Because now, if I rewrite my integral, the square root of x in the numerator, I can write that as u minus 1. And then 1 plus square root of x, I could just write that as u. But now I don't have this extra dx, so I would assume from this point, I would have to, well, take the derivative. The derivative here would be du. But I run into another problem, because if I take the derivative, at this point, the derivative of square root of x, if I just think of it as x to the 1/2, would lead me to 1 over 2 x to the negative 1/2. And this would be 1 over 2 square root of x. And I don't have that. I've already used up the square root of x right here. I've already used this 1 plus square root of x over here. I don't have this additional 1 over 2 square root of x. So this also doesn't match up at this point. So what I could do even further, because I don't have this, is, well, what if I were to take this and, let's say, working with u minus 1 equal to square root of x. What if I were to square both times? If I square this side and square this side? Because now I would have u minus 1 squared. Square root and the square cancel off. Because now if I take a derivative here, I do in fact have dx by itself, and the derivative on this side would be the power rule, 2 u minus 1 du. So this in fact is what you would have to do, is you would have to do a u manipulation, but because you don't have this additional square root of x, you have to simplify this even further by squaring both sides, and then you would be able to replace dx with 2 u minus 1 times du. So when I have this dx, it's going to get replaced with 2 u minus 1 du. Alright, so simplifying this even more, I'm going to go ahead and move this problem down over here. You don't have to draw this arrow, I'm just going to go ahead and move it over here. This 2 is a constant. I'm going to factor it out. So it's 2, and then the integral of, I have u minus 1. I have u minus 1 times u minus 1. So I'm going to square that, and then put it all over u, du. And I'll go back to my limits in just a bit, because I do still have to evaluate it from 0 to 4. So u minus 1 squared, I can expand that. So this problem, like I said, is challenging because there are a lot of steps and there's a whole lot of algebra. So u minus 1 parentheses squared is the same thing as u squared minus 2u plus 1. So I'm going to write all this out. So it's 2 times the integral of u squared minus 2u plus 1 all over u du. And then you just go ahead and split this up term by term. So it's 2. This is u squared all over u minus 2 u over u plus 1 over u all du. And then simplifying this some more, I have this just reduces to u. This is minus 2, and this is, I'm going to write this as u to the negative 1 du. I'm still multiplying all that by 2. Now all these are in terms of u, so I'm going to go ahead and change my limits at this point. And I plug in 0 into my initial u, which is going to be 1 plus square root of x. 0 plugged into here gives me 1. And I plug in 4 into here. It's going to be the square root of 4, which is 2, plus 1, which is 3. So my new upper and lower limits are going to be 1 and 3, respectively. And then I go ahead and integrate this term by term, so it's going to be 2. Antiderivative of u is going to be u squared over 2. Antiderivative of 2 is 2u. And then u to the negative 1 is ln absolute value of u. And all this is going from 1 to 3. And then from there it's just a matter of simplifying, plugging in the 3, plugging in the 1. So it's going to be 2 parentheses 3 squared over 2 minus 2 times 3 plus ln of 3. So let me put parentheses around this. And then minus the lower limit, which is going to be 1 squared over 2 minus 2 times 1 plus ln of 1. Close that parenthesis. And then close this parenthesis, because at the very end I'm going to multiply my answer by 2. Now this problem has already taken close, more than 8 minutes, so I'm not going to simplify this at this point. I will go over the simplified answer tomorrow, but I just want to go over, the basic technique is you do a u manipulation. You do as much as you can with this. You realize you don't have this additional square root of x in the denominator, so then you have to manipulate this even further, and then it's just replacing everything back in terms of u. Alright, so I'll go over the simplified answer of this tomorrow. I do want to get you guys some u-try problems. So I'm going to put up 3 problems. You go ahead and just copy them down and try them yourself. And then in class tomorrow, I'll check the notes and I'll check that you've at least attempted the 3 problems. This is the first one. This is the second one. And then the last one is this one. So tomorrow, I'll check that you've tried these 3 problems. They do require different integration techniques. Some require just a regular u sub, some require a u manipulation, some require you to just simplify it. So I'll go over these tomorrow with you guys. And here they are again in case you didn't copy them down. And that's it for this video.